How does Earth stay in orbit? And for other planets, how do they stay in orbit too? In order to answer that question, the first thing we have to do is talk about what is an orbit. An orbit is the path that something takes around something else. In this case, planet Earth follows a path around the sun, and so does every other planet in our solar system. They all have their own unique path. Now, when we actually look at the planets through a telescope, we cannot see that path. We draw these lines to help us understand the path that they take and to see the path that they take so that the planets don't run into each other. But there is no line in space. They follow this path. Now we're going to talk about why that happens. Gravity is a force that pulls everything down to the center of something large. On our planet, gravity pulls everything down to the center of the Earth. Now, anything that is big has a lot of stuff that it's made of, has gravity, like the Earth and the sun. The sun is much, much, much bigger than planet Earth. The sun has a tremendous amount of gravity. The larger and more mass or stuff something has, the more gravity it has. So, Earth has gravity, the sun has gravity, and each of the other planets in the solar system all have gravity. Also, they are affected by the gravity of each other. So while on our planet, for us here living on planet Earth, we experience the Earth's gravity with everything dropping. When we throw it in the air, all things drop back down to the surface. And when I jump, I jump right and fall right back to the center of the Earth. When I throw a ball, it comes back to the surface of the Earth. Now, if it wasn't for all of the layers of the Earth that are also pushing back out, that ball would fall in towards the center. But our Earth is affected by the gravity of this massive thing over here called the sun. So all of the planets are actually being pulled in to the sun. If Earth wasn't moving, we could stop it from moving, it would be pulled by that gravity into the sun. But Earth is moving. It's following an orbit. And because of that, it's actually moving sideways compared to the sun at about 2 miles every second. So the Earth isn't moving fast enough to escape the sun's gravity and leave the solar system, but it's going too fast to be pulled into the sun. So it keeps going around and around, orbiting the sun. You can think of it kind of like a tetherball. Think of the top of the post here as the sun, and the ball here as the Earth. The string between them is like the force of gravity keeping them the same distance apart. When you hit the tetherball, it spins around the post. If there was no air, there was no rope, and there was no friction, then the ball would spin forever without getting any closer to the post. It would just keep spinning around and around and around and around and around and around. But that isn't what happens on our Earth. But that is an analogy or similar to what happens in space, where there isn't friction because there isn't air, And gravity is really focused here on the sun. There isn't, Earth has its own gravity, the sun has its own gravity. But when Earth orbits the sun, it's in what we call a vacuum. That's a place where there's no atmosphere and no air. It does not lose speed to air friction, so it just keeps going around the sun. It stays in that path because it's being pulled in by the sun. But scientists think that when the Earth was formed from a ring of material that was moving around the sun, those pieces were drawn together. So if you've seen our video on how the Earth was formed, you'll see a picture of what that may have looked like. And as those rocks and dust clumped together to form the Earth, that path and that energy that those clumps were traveling on stayed. And because there's no air in space, and that air is not pushing back on Earth as it travels through space, it has continued in that path ever since. So if you were riding your bike down on a flat area, and you were riding it in a place where there was no air and no friction, no air would be pushing you back and slowing you down, and there would be no friction between the tires and the surface that you were riding on, and no brakes, you could continue riding your bike on and on and on with potentially no end, except you wouldn't be able to breathe because there was no air. Now see if you can explain, how does the Earth stay in orbit?